Well, the standard model is based on a symmetry called local gauge symmetry. And in local gauge symmetries, the masses are zero, but we know the masses in nature are not zero. So there has to be a mechanism to break this symmetry. The mechanism that is put into the standard model is a so-called Higgs mechanism. And the idea there is that all of the space is filled with a field called the Higgs field, and that when particles interact with the Higgs field, they acquire mass. And that is the point of view. And the Higgs field is an important pillar of the standard model because it gives these particles masses, and of course particles in nature have masses. So it is important that the Higgs be discovered to confirm the standard model, as the standard model is written down today. However, if the Higgs is not discovered, there probably is another mechanism. In fact, there has to be another mechanism, which will be equally interesting, that is required to break the symmetry, to allow the standard model to be an operative model. And there are some candidates for it, for such a symmetry breaking mechanism, and there are probably types of effects that we don't even know about which would do the same thing. So if the Higgs is discovered, it will be a great triumph for the standard model as it is written down. If the Higgs is not discovered, I think it is practically certain that there is something else in nature which is equally interesting and maybe even more interesting that will create the symmetry breaking required by the standard model. And why do I say it's required? Because the standard model is so good. It accounts for everything we observe at current accelerator energies, and even the initial results of the LHC give great confirmation of the standard model. So if the standard model is so good, symmetry breaking must be there. There must be a mechanism. If it's not Higgs, it is something else.